Alright, this is question 9 then about the circle on this summer 2008 paper. Find the equation of the circle with radius 10 and centre 2, 1. Giving your answer in the form that's given there. Well, this is quite a nice start point. If the equation has a radius, if it's got radius 10 and centre 2, 1, we know this form. We've learned this form. And that is the centre and the radius there. So if it's the centre is 2, 1, we can just replace A and B. X minus 2 plus Y minus 1. And the radius is 10, so 10 squared there. That's it. That is the equation of the circle. Centre 2, 1 with radius 10. We wanted to give it in this particular form. All we have to do is multiply out the brackets. X squared minus 4x plus 4, y squared minus 2y plus 1 is equal to 100. Let's tidy it up, get it in exactly the form they wanted. So x squared plus y squared minus 4x minus 2y. What we got with numbers there, we've got 4 plus 1, take away 100. So we've got 95 in there, and that's it. That's a pretty good 3 marks. Part 2. We're told that this circle passes through the point 5k where k is bigger than 0. Find the value of k in the form p plus root q. Well, we've got some choices about how we do this. We've got 2 forms of this circle. Now, they did ask us to find it in that form, but maybe this form will be easier to work with. So let's stick with this one. We know that they're equivalent. So part 2, it passes through the point 5k. So x equals 5, y equals k. That would be 5 minus 2 squared plus k minus 1 squared is equal to 100. And the question wanted us to find k. 5 minus 2 squared, that is 3. Squared is 9. So we're there. So k minus 1 squared is 91 if we take away the 9 from both sides. We want to find k, so next step is to square root it. K minus 1 is plus or minus the square root of 91, because remembering whenever we square root we have to write plus or minus. 91, are there any square numbers that go into 91? I'm not sure that there are. It's not a prime number, is it? 91 would be, well, 7 goes into it, I think. 13 times, but 7 and 13 are both prime numbers, so there are no square numbers that go into it. So we're stuck with that. So k is 1 plus or minus root 91. And we had to write it in the form p plus root q. It did say that k was bigger than 0, so it can't be the minus root 91 bit. So k must be 1 plus square root of 91, and there we are, done. I'm not liking that number, so I'm hoping that we don't have to use k anymore in this question. Part 3. Determine, showing all working, whether the point minus 3, 9 lies inside or outside the circle. Well, you know, this formula here is much nicer, really, because this tells us that for any point, the difference between the square of the difference between its x value and 2 plus the difference between its y value and 1 squared, that is going to be equal to 100 if it's on the circle, because that's the radius. It's basically all that stuff about the difference between 2 points, all the straight line stuff about using Pythagoras theorem. So let's stick with that form and let's put minus 3, 9 into it. We had, what do we have? X minus 2 squared plus y minus 1 squared equals 100. Well, if this 100 is the radius, if we put these values into this expression here, these are telling us the distance of this point from the centre of the circle. If that distance is bigger than 100, it's outside the circle. Less than 100, it's inside the circle. So that's all we need to do. Let's sub them in. Minus 3 minus 2 squared plus 9 minus 1 squared. That is equal to 25 plus 64. Which is 89. Which means the distance of the point minus 39 from the centre of the circle is the square root of 89. And the square root of 89 is less than 10. That's less than 100. So it's inside the circle. If that had come out as being exactly 100, it would have been on the circle. More than 100, it would have been outside the circle. That's all there is to it. Find an equation of the tangent to the circle at the point 8, 9. Well, I'll go on to the next slide for this. This is the key bit here. What did we have? We have a circle. Oh, I don't know why it's done that. Oh no! Let's see if we can change that pen. There we have our circle. What we do know about circles is if we want to draw a tangent to that, it doesn't matter where it is, we know certain things about the way that circles work. We know that line there, the radius, meets the tangent at 80 degrees. And so if we can work out some of the gradients that are going on here, then we can sort this. We've got, what have we got? We've got that the centre of the circle is the point 2, 1. We've got the point where it meets the circle is the point 8, 9. I'm not so sure about the scale of my graph, but it will do. And we want to find the equation of the tangent to the circle at that point. Well, all we need to work out is we've got a point on this line, we need its gradient. The radius gradient, well, remember gradient is change in y over change in x. So that is 8 over 6. So 4/3. So the gradient of this radius here is 4/3. The tangent is perpendicular to that, at right angles to that. Tangent is perpendicular, and one of the things that we know is that perpendicular lines, the tangent of perpendicular lines, or the gradient of perpendicular lines, is the negative reciprocal. So we turn over 4/3 and we make it negative. So we now know that this line here has a gradient of minus 3/4 and it passes through the point 8, 9. I said we'd come back to this, we wrote this down earlier. We're going to use y minus y1 is m x minus x1. We've got n is minus 3/4. We've got our point is the point 8, 9. And so y minus 9 is minus 3/4 of x minus 8. Slightly unusual here, it just says find an equation of the tangent. And actually, we've done it. It's not a nice way to leave it, but we have found an equation of the tangent. More normal is for the examiners to say, write it in the form ax plus by plus c equals 0, where a, b and c are integers. For some reason they didn't here, but we will do that just because it's the nicer way of finishing it off. If we times everything by 4 and multiply out the bracket, it looks like that. And then I think we might like to collect everything together on one side. So 3x plus 4y, what have we got there? Minus 50? 60, sorry, is equal to 0. And that would be our equation of the tangent. Alright, and that's it done. It's funny how that last bit of the question there didn't actually rely on any of the knowledge from earlier on. It didn't need anything. All of that was given in the question. So even if you can't do circles, and you couldn't do any of the earlier bits, that final 5 marks was still instantly accessible to you. There we go.